So glad to have you here. And for those who are not familiar with either Angeline, Azin, of the work at Georgians, you're in for a treat. They're doing some really awesome work. They're really exploring where research can lend itself to industry. So I'm very happy to have them present for you today. So Angeline, for those who don't know or haven't heard her speak at any past events, works on data science initiatives and data modeling for Georgian's internal machine learning software. So her research interests revolve around how to properly incorporate machine learning in real world applications, building a fair and generalizable model, and also making ML models explainable. Azin leads Georgian's internal and external applied machine learning projects in collaboration with their portfolio companies, as well as Georgian's monthly paper clubs. So her research interests lie broadly in the fields of machine learning, computer vision, and transfer learning. And today they're going to speak on enhancing ML app with wisdom of the crowd. So without wasting any more time, I will hand it over to you.
Sure. So hi everyone. Thank you, David, for such a nice introduction. I'm Angeline, and I'm here with Azin, and we're going to talk about enhancing machine learning app with wisdom of the crowd. So Azin and I were talking together about why should we care about the crowd's opinion? Because essentially, wisdom of the crowd is using the crowd's opinion to make better prediction. I guess historically, we found that in our personal experiences, consulting with other people, getting other people's perspective helps us to make better decisions because they usually have other perspectives that we're not familiar with or we're not we didn't really detect before. So in today's presentation, we're gonna first start with a little bit of introduction, and then we're gonna go into what is wisdom of the crowd, what does it mean in machine learning, why should we use it, and just some recap and questions. So who are we? Azin and I are both applied research scientists at Georgian. We're part of the R&D team, and Georgian is a fintech that invests in startup companies. So actually, Georgian consists of a mix of people like operators, machine learning scientists, and also investors. So you may wonder, why is an investment firm, why do they have an R&D team? And the reason why is because the R&D team in our firm drives product differentiation in our companies, the companies that we invest in. So the R&D team accelerate adoption of differentiating technology trends like AI, trust, and conversational AI. So our team does some research. If you'd like to know more, you can take a screenshot of this slide, or we have a QR code here for our research links. And also we have some open source toolkits. All right, I'm going to hand it off to Azin.
Thanks, Angeline, for the great introduction. Hi, everyone. I'm Azin, as Angeline mentioned, I'm an applied research scientist on Georgian's R&D team. So Angeline brought up a great question. What is wisdom of the crowd, and why really we care about the crowd's opinion? So wisdom of the crowd theory simply states that a large group of people are smarter than individual experts when it comes to predicting. And some people claim that this theory is originally proposed by Aristotle in 380 BCE. But this is a very intuitive theory for us because we see many different real examples in our lives on a daily basis. For example, social information platforms like Quora, Wikipedia, Glassdoor, Stack Overflow, they all rely on collective human knowledge, and they're basically all based on this theory. Or to take another example, we make a lot of our decisions in a group, which is another perfect example of this concept. But like any other concept in life, there are cases where this theory fails. And an example of that can be a mob attack, which we'll cover later in the slide. So we'll talk briefly also about in which scenarios this theory doesn't work and fails, and for, basically to be careful about. So now we covered a few real-world examples. If you would like to read more and see more of these examples, I highly recommend this book, Wisdom of Crowds by James Surowiecki. This book is written in 2004, and in this book, basically, James presents his arguments by providing numerous case studies and examples. So this is a very interesting book. If you hadn't had a chance to take a look at it, highly recommend that. But so for the rest of this talk, we're going to mainly focus on the concept of wisdom of crowds in the context of machine learning. And I'll pass it to Angeline to explain how we can leverage this concept to train AI models that are more accurate and more explainable.
All right. So wisdom of the crowd in machine learning, as some of you probably already know or guessed, is that we would like to use the output of many models instead of just one model. So this is also called ensemble learning, which I think is pretty well known in the machine learning community. There are different techniques to the machine learning, and I'm just going to go over them really quickly for those who are not as familiar. So the first technique is called bagging. So bagging is when we train many models, and each model is trained on a subsample of the data, or it can also be the subsample of features. And then we aggregate all the models together. So the most popular example of this is random forest, when they train a big tree on subsample of their data, and then they aggregate them all together. The second technique is called boosting. So in boosting, we train a weak model one iteration at a time, but in each iteration, the misclassified samples from previous iteration will be upweighted so that we can pay more attention to the misclassified samples. So the example for this is gradient boosting trees, or XGBoost. The third technique is called stacking. So stacking is also when we train a lot of models. The models can be homogeneous, meaning they can be the same infrastructure, or they can also be heterogeneous. And then after training many models, we can have like a meta classifier that takes the input from all the outputs of the different models. The meta classifier can be trained, but it can also be as simple as averaging or majority vote. Although there's a warning, this technique may not work well if your submodels are very weak and you may have a mob riot, like Azin explained earlier. Okay, so now you may wonder, why should we use all these techniques? Like, why should we use ensemble learning? And the first reason, I think Azin also mentioned, is for sure to get a better prediction. So a lot of people have shown that ensemble learning can reduce your errors. If everyone here is familiar with the term bias and variance, ensemble learning reduces the bias and variance. It also increases the diversity of insights because you're getting information from different models, not just one model. So an example here, for example, let's say you have a KNN, random forest, and naive Bayes. You can have a meta classifier that combines all of these different models, and you can learn different things from all of them. And it shows that you get a better performance in the end by combining all of them. The second reason why we should use ensemble learning is actually to explain model easier. This may be counterintuitive, but I'll explain why. So there are some problems with explanation. So nowadays, there are many explainability methods available. I think there's SHAP. You can also use LE5 library. But the problem the research community is finding is that these...
Oh,
yes?
sorry to butt in. We are only seeing the, we're not seeing the slides. We're only seeing the title slide.
Oh, really?
But I guess I can see the slides.
Oh, okay. Sorry then. Maybe it's just me. Sorry.
Oh, yeah. People
can
can
also
see the
see the
slide.
slides.
All right. Thank you, Faraz. Yeah, if there's any problem with the slides, please let me know. So going back to the problem with explanation, so the research community found that the explanation that these methods give, so these methods give feature importances that are important to the model, but they can actually be unstable, especially when you deal with noisy data or when you deal with a huge amount of features. So we did some experiment in-house, and we found that as the number of feature increases, we get lower stability. And then also we found that when we use explainability methods, if we give too much information, and that can happen when you have many, many features, it can actually reduce transparency because your end user is kind of like in an information overload. There's too many things to see. So with ensemble learning, we can actually get better explanations by doing the following. So let's say we train a lot of models. Each model is trained on a group of features. And then we combine the output of all these different models with a meta classifier. So here we can get an easier interpretation of the explainability results because the group of features are brought to a higher level, so it's not as granular for the user, and it's also more stable. Although there is a caveat, so it may impact performance because there's less interaction between the granular features across the different models. So the way you group the features have to be done in a certain way, and it can only apply in certain cases. Right, Azin.
Thanks, Angeline. And yes, so the third benefit of using ensemble learning is that you can use it to address the cold start problem. But what is actually the cold start problem? Maybe let's start from there. So over the past few years, we have all heard many successful stories of applying machine learning models in production. But those stories usually come from supervised learning models. And as we all know, these models are pretty data hungry and they usually require huge amounts of labeled data. But collecting data is often very expensive and time consuming. So the effect is basically, as a customer, you may experience very long onboarding time and you may start get frustrated or not wanted to proceed with that service. And as a business owner, you may experience an increase in the time to value add because it takes longer to serve your customers and actually gain the value you're looking for. So this is one of the common problems that companies face during different phases of their. For naturally, because we work with many companies in growth stage, we also face this problem often. But now let's think about how we can solve this problem. So imagine you have access to N models that are trained previously for your other customers. Through a combination of the techniques that Angeline mentioned earlier in the slides, you can basically combine this model and train a new model for your new customers with just having access to very minimal amount of data. So the analogy of this is basically like if you have many different experts in a room, then you can combine their opinion and hopefully you can create an Einstein out of them. So this way, hopefully you can convert your cold start problem into a warm start by leveraging the models that you already have access to and you have already trained for your previous customers. Thanks, Angeline. So now we'll talk about one of the use cases, applications of ensemble learning that we have recently worked on. So Tractable is one of our portfolio companies. They're located in London, UK, and they're basically on a mission to automate the whole car appraisal process. As one of their services, they have an AI platform where you can upload images of your damaged car, and basically the AI models will create a cost estimate for you within a matter of few minutes. So Tractable is currently in 13 countries, over 3 continents, but they're expanding and growing very rapidly, and they would like to get to all existing 195 countries in the world. But they're facing a cold start problem simply because cars around the world look very different. So we had a collaboration with Tractable's R&D team where we leveraged a combination of the techniques that Angeline mentioned earlier in this talk, and we could help them to address the cold start problem to some extent, which helped them to basically increase the performance by 20% with having access to 10x less data, which reduce the cost, and decreasing the human effort required for onboarding by 25%. And this all helped them with differentiation and brand elevation.
So cool. So just to recap all of our talk of these cool things, wisdom of the crowd or ensemble learning can be used for getting better predictions, increasing model explainability, or if you're a business that's growing, like Azin was just talking about, can also overcome cold start problem with ensemble learning. Thank you so much for listening to our talk. Georgian is hiring, so if you'd like to see our job openings, you can check out the georgian.io/careers website. Can also DM us on LinkedIn to join our monthly paper clubs that Azin is organizing. And also, we have some exciting news to share. Where the tool that was used for tractable case study is actually being now worked to be an open source toolkit. It's going to be called an ensemble toolkit, also called ET. You can watch for updates on our GitHub repo over here. It should be out around a month or so. It supports heterogeneous ensembling and stacking. It's also scalar compatible. And all this work is being done by Chris.
Yeah, so just to quickly also add another update, this is actually more, so the ensemble toolkit that we will release later in the next coming months is going to be very generic toolkit. So we have used a similar approach for different projects. So this is basically just kind of like finding all the interesting parts that can be used by other people and sharing them. We'll share more details on this later, so stay tuned by checking our GitHub webpage.
That's great. Thank you, Angeline, and thank you, Azin. So Ali has a question. He asks, can you share an example of an explanation created by Ensemble?
So an example, so essentially it's the same as the normal explanation. It's just we're just getting the explanation from the meta classifier. So the feature importances are which model output, which submodel output come out as important to the meta classifier. So it's in a sense a higher level view of which features are important. It's more like which group of features are important. Does that make sense?
Yeah, well, it does. Thank you. I'm curious, where would you see or intuition as to which applications you're either seeing some interest or your team predicts that this might be particularly useful for?
For the explanation or all the things in general?
The explanation.
So in our data, we found that sometimes we work with data where we have tens of thousands of features, and the feature can be very granular and not necessarily human intuitive. Like it may give certain signal, but doesn't really make sense on its own. So when we show the feature importance to the user, they're like, why is this feature important? Like, what does this mean? Why is this feature showing up as important? So we found that in those cases, if we group the features in a more human readable kind of way, it's more interpretable for the human, for the end user.
Thank you. Azin, did you want to add to that?
I thought you're basically asking more generally about the applications of ensembling, not specifically on explainability.
I would also be interested in that. Yeah, so I guess both, we've touched on the explainability component, but yeah, just maybe ensemble in general. Is there anything that you think is ripe for folks to sort of adopt and utilize this with?
Yeah, so from From my personal experience with like using these sort of methods, I think they're actually like great natural fit for problems where you wanted to break a very challenging and complex problem into smaller building blocks. Like you know, this is basically, I think, the way we do solve these sort of problems as humans naturally. Like if I'm getting a very, very difficult problem, I'll try to break it into smaller pieces, solve those pieces, and then put them together to kind of like solve the ultimate problem. Yeah, and I feel like for cases where we're like trying to solve a challenging problem, where we're also interested in the smaller building blocks of that problem, that just like naturally a really nice fit to use these sort of ensembling techniques. They have been shown to, like, you know, if you check Kaggle's competitions, you can see a lot of like promising results. Almost all like winners of Kaggle competitions are using one of these techniques, either stacking, bagging, boosting. So they've also proved to be to provide very accurate predictions and great performance overall for various problems.
Enrico asks, how likely is it that the crowd can maliciously the models?
That is a great question. Yeah, so as you know, like as we have also seen in real life, there are some scenarios when you can see like you know, kind of like poor decisions being made by a group of people. I think one factor that is really important is like you would also see this kind of like assumptions for ensemble models. And that assumption is like basically you don't need to have very strong base learners, but those should be performed at least better than random. Like if you combine a bunch of models and each of them is performing worse than random, or they're basically doing nothing, then you shouldn't expect to get any performance out of it. I think the same also analogy applies to human. So if you put a bunch of people in a room and none of them are experts like in that topic, or like they're just gonna create random theories, I think you shouldn't rely on the decision made by that group of people. So basically, I think that would be my answer to that question. Angeline, do you want to also chime in?
I think you described it perfectly.
Some tough questions getting asked here. This is good. Okay, next question. The effect of outliers and bias, how is it handled? Is it done at different blocks as a specific pre-processing step? As each learner has a specific objective, do you set it up as a part of data processing?
Sorry, is this more on the bagging or boosting, or generally like?
Or I guess it's more related to the, for example, maybe in the cold start problem, you had models of different countries or different customers. So it may bias, it's biased in a different way for each model. Is that what you're trying to say? Yeah. Okay. Yeah, Azin. So like, for example, in Tractable, there are different models from different customers. So
Yeah,
each has their own bias.
I think that's like that not very specific to Tractable's problem. So it's kind of like a specific. It's a case that you would probably have to face in any sort of problems. And I think the advantage of ensembling is to have models that are biased toward things. Like if all of your models are basically saying the same thing, you don't have any diversity, and there is no like opposite opinions, then there is nothing to benefit from compared to just having a single model.
That's great. Yeah, and if anybody has any questions last minute, feel free to get those in. One question I have is, Azin and Angeline, do you have any, or perhaps even this is a question we could ask Christopher, what are, if any, the goals of this as an open source project? Where would you like to see this go? What might be the expectations that you have for it?
That's a great question, Dave. So for the, I'll go first, Angeline, please feel free to add anything if I missed. So for the ensemble toolkit, this is an work in progress yet, so we don't know all the details yet. One thing that we have seen previously is being just able to combine a bunch of models that are not homogeneous is something very, very beneficial and reusable in different projects. And when we were looking for such sort of like, open source libraries, we didn't find anything outside. So most of the existing open source libraries, they allow you to do ensembling only in certain scenarios when, for example, your models are all the same or your models are all trained on the same data. Like there is certain assumptions that creates a lot of constraints. And we wanted to kind of go beyond that. So that's the main goal of kind of like building a toolkit by ourselves. But we're not like 100% sure on the roadmap yet and the features that we're going to release. So we will share more details on this page. You can like stay tuned. Please check the page and link shared here. We'll share more details as we kind of like decide about our roadmap and the features that we're going to release. We have been able to successfully use this sort of like techniques in different projects. One of them being tractable, but we haven't fully like finalized from basically what would benefit the general audience and what would worth sharing with the public. So this is still a work in progress, and we'll share more details. Please stay tuned. And yeah, if you would like to, if there is anyone interested to help with this work or get more information, you can like just message us on LinkedIn or email us.
Yeah, that's great. Thank you, and we'll do our part to make sure to send everybody those notifications and news as you get it. Please feel free to share, and we'll pump it into our channels as well. So thank you very much, Azin and Angeline. We really appreciate it. Wish you both the best, and it's good to see you both again. We're certainly excited to see how this rolls out over the next year. But in the meantime, thank you so much, and I hope you enjoy the rest of your day.
Thanks, Dave, and everyone. Have a great rest of the day.